Hello student, today in this video we are going to discuss about the equation of motion of class 9 physics ICSE board. So student, in the previous video we have already discussed about the rest, motion, and how rest and motion are just has their important relations between them, and speed, velocity. Now in this video we are going to discuss about the equations of motion. Okay, generally there are three equation of motions, and with the help of this diagram we are going to discuss it. Okay, so just see clearly. First of all, in order to understand this graph, we should always just came in one conclusion that all the equations of motions can be derived from the velocity time graph. Okay, means velocity time graph always gives the acceleration. So in velocity time graph we are getting acceleration, and equation of motion is also concerned with that. So we will one thing that you have to keep in your mind, that acceleration is always obtained from the velocity time graph. This is velocity time graph. Okay, in this diagram we will understand that suppose a particle is moving from O to A. Okay, and this is the initial velocity. This is initial velocity. After that it has a graph AB. Okay, the final velocity of this graph AB will be V, capital V. This is final velocity and this is initial velocity. Means the particle is moving with the initial velocity U, and it reaches up to final velocity V. Okay, then how we first of all we will find the equation of first equation of motion. First equation of motion, this is suppose the first equation of motion. First of all we will derive first equation of motion. Okay, how we will find the first equation of motion? In order to find out the acceleration from the velocity time graph, in order to find out the acceleration, means acceleration is always obtained is equal to slope of the graph. Slope of the graph, slope of the graph line, the graph line AB. Okay, this is AB. So in first of all acceleration of a moving body is always obtained from the obtained by finding the slope of the graph. Means whatever the particle is moving from A to B, we will just find out its slope. Okay, so what will be the slope? Means acceleration A will be equal to is equal to what will be the slope? The slope will be just from the initial to the final, if you are considering the x and y axis respectively. Okay, this is y axis, this is x axis. So it will be, the slope will be y axis divided by the x axis component. Okay, so acceleration will be equal to just BC upon AC. Okay, this will be the slope, this will be the slope, BC upon AC. Okay, what we can write here? BC will be obtained as we can write here BC, instead of BC we can replace it BC by BD minus CD. BD minus CD, we will obtain BC and BD minus CD. Then we can write in place of BC BD minus CD, BD minus CD divided by AC. Okay, after that what we can write? We can write BD is V, and CD is U. So what will be the VC? VC will be V minus U. Here we are writing here BD V, CD will be U. Okay, And what will be the AC? AC is already time t. So acceleration equal to v minus u upon t. And we already know that acceleration of any body is always equal to the rate of change of velocity. Means the velocity is changing here, means it is always changing, means the rate of change of velocity is changing. The rate at which the velocity is changing is acceleration. That is, this is v minus u, final velocity minus initial velocity. This is the change in the velocity, and when we are dividing by t, it will just find out the rate. So acceleration is equal to the always rate of change of velocity. Okay, after that what we can write, we can just apply the cross multiplication here. So v minus u equal to at, or we can write that v is equals to u plus at. And what this is first equation of motion. Okay, now this is the first equation of motion. Now we are going to discuss the second equation of motion. How we will able to find out the second equation of motion. Okay, this is all about the first equation of motion. This is first equation of motion. Okay, now we are going to discuss about the second equation of motion. Okay, how we will able to determine it. We know that from the velocity time graph, the area under the graph, means whatever the area it is just concluding, the area under the graph always gives the displacement. Means one thing we should know, we have to know that the area under the velocity time graph always gives the displacement. So in order to understand the displacement, in order to just derive the second equation of motion, we will write that area means displacement is equal to the area under the graph. And what is the area under the graph? Just see here that OABD is in the form of trapezium. It is a form of trapezium in which AO is parallel to BD, means these are the parallel lines, these are the parallel. Okay, and OD is the perpendicular distance between them. So if you will find the area of trapezium, then we will easily able to understand the displacement. Displacement will be easily obtained from here. So displacement will be equal to the area of the trapezium, O, A, B, C, D. And what will be the just formula of trapezium? Half into sum of parallel sides, means OA plus BD into height OD, means 1 by 2 into OA is initial velocity we have taken earlier, BD is the final velocity, and OD is the time. Okay, and we will now substitute here u. We know that v is equals to u plus at. From the first equation of motion we already know, so we will just substitute v with this value. So we will write here v is equals to u plus at into t. Okay, now 1 by 2 into this will be 2u. Okay, and this will be 80 into t. And if we just multiply it throughout, 1 by 2 into 2ut, okay, plus 1 by 2 80 square. 2 cancelled out, so what will be here? Ut plus half 80 square, and displacement is represented as s. Okay, we can write here as, this will be s. We can easily able to just Yes. So s equal to ut plus half at square, this is the second equation of motion. This is the second equation of motion. Okay, this is the second, means this just once again we will just going through here. The second equation of motion, that displacement is always obtained from the velocity time graph by finding the just area under the graph that is the area of the trapezium of the figure, that is OABCD. We know that area of the trapezium will be 1/2 sum of parallel side into time or height. So s equal to 1/2 into u plus v into t. In place of v, we are substituting v here, v equal to u plus at here. So while substituting here, we are easily able to get the trapezium area of the trapezium. In order to that, we are able to easily find out the displacement from the velocity time graph. Now, in order to find out the third equation of motion, we will just follow the same procedure as we have just derived the previous equation of motion, that is a displacement. Where in order to find out the displacement of a moving particle, we always just consider about the area of the region in which the particle is moving. So displacement is equal to the area of the trapezium OABCD, means s equal to 1/2 sum of parallel side into perpendicular distance, that is OD. So what we will write here, s equal to 1/2 into u plus v into time t. Okay, now in this case we will write here, that is we know that the v is equals to u plus at. Okay, and from this only what we will write, v minus u equal to at. So at equal to v minus u, or t is equals to v minus u upon a. Now in place of t, we will substitute t with this value. Okay, with this value v minus u upon a. Okay, what we are getting here by substituting it, let's see, 1/2 u plus v into what will it will be v minus u upon a. Okay, we have already substituted here. Okay, what we will getting here, s equal to, means displacement equal to 1/2 into we can write here v plus u, and it will be v minus u upon a. Okay, we are just observing here that here is v plus u, v minus u, that is a plus b into a minus b, means here is also formula that a plus b into a minus b is equal to, we know that a square minus b square. Okay, so we are just substituting here v square minus u square upon a. If we are just making cross multiplication, what we will get here, that 2as equal to v square minus u square. Okay, or just v square minus u square equal to 2as. This is the third equation of motion. This is the third equation of motion. Okay student, with all these just equations, we will just do a various numericals also later on. So I hope that all these three equations you are just cleared. You just go through. We will meet in the next video, and I hope that you will just if you want to see this, you will just clear your just concepts with this video, and we will meet in the next video. Thank you.